I've been busy working on my automation game that I'm making in Godot, and the progress has been really good. I added 5 new machines, fixed a bunch of bugs, and upgraded the conveyor belt system. In this video, I'll show you what I worked on each day, as well as some of the things that I got stuck on. On day 1, I didn't have too much time to work on the game, so I added a simple but necessary feature, which is the ability to delete tiles. This way I could remove belts and machines by right-clicking. I had to also make sure that any resources that were in that machine's inventory or were on their way to it were also deleted to avoid being left with these floating items. Day 2 saw the addition of a new machine, which was going to be the combiner. The idea is that the combiner would take 2 inputs at a time and then combine them into a higher tier item. I wanted to make this machine take up a few tiles, so that's how I initially drew it up. But I then realized that adding a multi-tile machine into my game would require a big rework since it wasn't set up for that in the first place. So I finished day 2 a bit unsure on what to do and feeling like I didn't actually have that much to show for the time that I spent working on this. And that changed on day 3 when I decided to scrap the idea of a multi-tile machine and keep things simple for now. I redrew the combiner as a single tile machine and reorganized my spreadsheets. I was then able to finally add the combiner into my game, and since it inherits the logic of the other machines, I can rotate it and place it in the same way. Day 4 saw some good progress on the combiner. The first thing to do was to make the combiner actually hold on to the item it's received, since the current behavior for the machines is to offload an item as soon as there is a free space in front of it. I achieved this by adding an internal inventory, which acted as a holding area for items waiting to be processed. I then added a check to make sure that if that inventory already had an item, then the second item couldn't be the same, but it will wait for a different item type to put into its second inventory slot. Once that condition is met and it has a full internal inventory, it then starts a timer and combines the items into a new one, which is then moved into its main inventory and is fed out onto the conveyor as normal. The one thing I didn't like was how the items had to take turns going into the combiner. So I also changed that behavior so that in any multi-inventory machine like this one, items can be accepted simultaneously. After the good progress of day 4, I kept up the momentum and added another 2 machines, a furnace and a market. The work I did on the combiner previously made these 2 machines much easier to add. The logic for the furnace was pretty much the same as the combiner, except instead of processing 2 items, it processed 1. But other than that, it had an internal inventory to store the input resource in, just the same as the combiner, and once that inventory was full, the furnace would then start working. It would turn that resource into a second tier item and offload it. I'm using a crate here because I haven't drawn up these additional resources yet. There was an annoying bug with the furnace though, where it would continue receiving items even though it was full, but eventually I figured that one out. The code was checking to see if the stored inventory was below capacity, and then there was an elif statement to see if it was at capacity. The problem was that the first if statement would add an item to the stored inventory, which would then take it to capacity, but since the second part of the code was an elif statement, it meant that after that happened, we never actually triggered the second part of the code. So now I've reworked it, it works much better. The market machine that I added was more like the compactor, since its only job was to receive items and then delete them. It didn't need to store or process them. The purpose of this market is to track what the player has shipped. So to visualize it, I've added this temporary banner at the top of the screen, and in there is a counter for each of the 3 resource types that I've got so far. When an item gets to the market, it's stored inside a dictionary, and those counters are then updated accordingly. On day 6, I worked on the next 2 machines, which were the merger and the splitter. They were pretty self-explanatory. The merger would have 2 inputs, which it would combine into 1 output, while the splitter would do the opposite. It would take 1 input line and split it into 2 output lines. This was when I realized that my code for moving items around had a pretty significant limitation. I didn't have a way of defining inputs and outputs on my machine. The way it worked up to now is that each belt looked at the one in front of it, and as long as the 2 belts weren't facing each other, then it was okay to move the item. This meant that by default, all of my belts and machines had 3 inputs and 1 output with absolutely no flexibility. To fix this, I added 2 extra properties to them, where I would store the inputs and outputs as vectors. This would tell me the directions in which each machine can accept an item or can output an item. The result was great and meant that the splitter and merger worked perfectly. Well, almost. There was a small problem with the splitter, which was that if the output was blocked, it wouldn't automatically switch to the next output. It would stubbornly wait until it offloaded the first output, then it changed to the second one. I broke this down into a little flowchart. First, the machine will pick the preferred output and check if it's free. If it is, then carry on as normal and offload the item. If it isn't free, then I make an array of the remaining outputs. I then iterate through that array, and if I eventually find a free output, then offload the item and exit the loop. This did the trick, and now my splitters were able to find an open path to offload their inventory. And with that, I ended day 6. One last feature that I wanted to add was a way of mirroring the machines. This isn't needed for most of them, but would be very useful for the splitters and the mergers. This actually turned out to be quite difficult, as there's no easy way to rotate and transform tiles in code. When you're manually placing the tiles, you do have a few buttons in the editor that make this quite easy. But doing it in the code requires the use of these flags, which are quite confusing to work with. There is an open issue on the Godot GitHub that asks for a way to simplify the rotation and the flipping of tiles on the tile map. And it does look like there's a fix that's been developed. So maybe we will see this in a future release, but for now I had to do it manually. I wrote a function that would combine the rotation and mirror transforms into one. I'm not going to try to explain it as all the variables will need context, but this function applies mirroring and rotation together into a variable called applied transform, which is then applied to the tiles whenever they're placed. And that is where the game is now. Some of the features that I talked about may seem pretty small, but they can take hours to implement, so I'm really pleased with the progress. The Notion dev board gives me a quick overview of the completed tasks. I got a few machines added in, as well as the merges and the splitters. I fixed some annoying bugs, put in a mirroring feature, and put in a big upgrade to the input and output system. There is still plenty more to do, so to make sure that you don't miss the next video, hit the like button, subscribe, and I'll see you in the next one.